Hi guys. In this session, I would like to discuss about linked list and one interesting thing called how can we reverse a linked list, right? So let's look at what a linked list is as a data structure. So linked lists were created to overcome some limitations that are present in the array data structure. So in arrays, the main problem that we always had was when we create an array of a fixed size to add more elements, it is always unknown that if we have an extra space to accommodate for that element. So so we need to declare a very large sized array to be safe initially in the program, but it's going to waste a lot of memory. And also there are some operations like inserting a value in this position is going to be very costly, because uh, we have to shift the element at this position to here, and then this, and the element present at this position to here, and so on. We have to shift. In the worst case, we have to shift n elements to the end to make room for the a new element to be here, to be put here. And also there are some kind of limitations as well, but we still use arrays because accessing any element in an array is a very fast operation. So arrays are very good when we try to access them, but when we need so so when the problem statement is oh, we need to constantly add and delete elements, then a linked lists are supposed to be better data structures. So what is the structure of a linked list? A linked list will have an element fundamentally called as a node. So this is what we call a node. A node will have some data and it will have some link. So what will the link have? The link will have the address of another node. So let's say this is another node. So this link part will contain the address of this node, and the link part of the other node will contain the address of the other. So it's going to form a chain, a list, a linked list, right? So let us take a linked list and see the problem that we are now going to solve. Okay, now let's say this is my linked list. Okay, so this is the linked list that I am taking. Right. So this is the node 1, this is the node 2, this is the node 3, and we have the links, and the last node's link will be equal to null because it is not pointing to anything else, so it will have null. And we have a special pointer called head. So head will always point to the first element of the linked list. So this is the general structure. Now what are we trying to do? We are trying to reverse this linked list. So the output that we want is a list like this, where 1 is here, so 1 is being pointed by 2, and 2 is being pointed by 3, and 3 is being pointed by head, and enter no ones. Okay, it's going to be null. So I want to reverse the direction of the pointers. So how can we do that? This can be done using three variables, actually two. Let us take let us say we have this variable. So let us say this is the element that we are processing, right? So this is my current. So I want this link to not point at 2, but to point at my a previous value. So for the first node, it should point to null, right? So we're going to initialize some previous pointer. A previous pointer will initially have the value null. So what am I going to do? I'm going to make current. I'm going to write current. I want my current values next pointer. I want my current values next pointer to be equal to this previous. Okay, so using that we have broken this, and now this is pointer null. But yeah, but we have an issue. So what's the issue? Here, as we have a break in this link, we don't have access to this address. So even before breaking this link, we have to make sure that we have another pointer which will hold this address, and let's call this as next. So we'll have the value next nxt. Nxt will store the current dot next value. The current dot next value, it will be stored in next, so that it will be pointing here. So now we have broken this link. Now what am I going to do? It's gonna, now we have to move our current pointer to here. So we're gonna say current is equals to next. So my current is equal to my next pointer. So now it's not pointing here anymore, now it's pointing here. And also I want my previous to be here, so I want my previous to be my current. Now I want my previous is equals to current. So we're going to repeat the same step of code till we get to stage where where current will point here, where current will point here, and current will also be moved to here. I mean, current will be pointing to null, and previous will be pointing to the last node, and next will always next is already null, right? So now we're going to return p, and this is going to act as a new head. So what's gonna happen? So we're gonna break this link. Now this will point to this, and we're also going to break this link. Now this will point to this. So literally we have made this look like we have null. So null is now pointed by the data 1, and here's the address, and now this is being pointed by 2, and this is being pointed by 3. So we're able to reverse this linked list using 3 pointers. So all these 4 statements will be in a while loop. So what will be the while condition? Until when should we do this? We should do this till current is not equals to null. If current is equal to null, that means we have reached the end of the list. Now our previous pointer is now holding the address of the last element, and our next pointer is already pointed to null. So we're going to return the value of p. It will be reassigned as a new head, and thus from the new head all we have is, so we'll be returning previous, and now this will become our new head, and thus our linked list is reversed. So in this way we can reverse a linked list. It's a very important program, and also it's very easy because you're only doing 4 steps iteratively, uh, and also this will work for linked list of any order, right? And yeah, so that's it. So that's the video about the reversal of a linked list. Hope you liked it. We'll meet in another video.